So he's talking about CH3 bond O and OH. He's saying that it's behaving as a stronger acid when it's in ammonia. So that kind of indicates that ammonia might be a very good base, which is why, uh, because it's a stronger base, therefore the acid is behaving as a strong acid. Ethanoic acid is a stronger acid in liquid ammonia compared to aqueous solution. Aqueous solution is water. Water might be a very bad base, which is why the ethanoic acid would not be able to lose the H plus one. Okay, is this clear? Ethan Mohammed, is this clear?
Yeah.
So the answer would be A. So always remember that that the acid, its behavior can be increased. It could be made into a stronger acid. It could also be made into a weaker acid. It all depends on the strength of the base. Okay, so if you use a stronger base, the acid would dissociate or ionize more. If you use a weaker base, the acid would ionize less. Let's move to the next one. The next one is which statements are correct? Ammonia behaves as a reducing agent. So is it behaving as a reducing agent? The charge in ammonia over here is -3. To get H is +1, N would be -3, and over here N is 0. So that means ammonia is getting reduced. So it's getting reduced. Goes not reduced, it's getting oxidized. There's an increase in charge that's happening. So not definitely not reduced. It's actually getting oxidized, and anything that's oxidized, that's a reducing agent. So ammonia is behaving as a reducing agent. TK, is this clear? Mohammed Ethan, is this clear? Minhail, is this clear?
Yeah.
Yes.
Acha, the second is ammonia behaves as
Sir,
a yes.
why do you take the one from N2 and not NH4?
Oh, in that case, it's nothing is happening because if you take NH3 to uh, NH4 plus one, then you would notice that if you try and find the oxidation state, it's going to be N is X. That's H is +1. That's into 4 times 4, and the whole thing would be equal to +1, right? And X still comes
Yes.
out to be -3, and X is -3 over here as well. So the thing is,
Oh,
Kate, nothing is happening there. So we were looking for whether there is something going on where it's behaving as a reducing agent. It was behaving as a reducing agent, okay? And the next one is it behaving as a base? As you can see over here, NH3 is changing into NH4 plus one. So that indicates that it is. Let me rub this off. So over here, what's happening is it gains H plus one, right? So that means it's behaving as a base. So the second statement is correct. And the oxidation number of hydrogen changes. It does not change. It is +1 everywhere. Hydrogen is +1 in any compound that it forms. So it's +1. Let's move to the next question, which is which statement best explains why this reaction should be classified as a Bronsted-Lowry acid-base reaction. The first one is the ammonium ion acts as a proton donor. So where's the ammonium ion? Uh, there is the ammonium ion and there is NH3. That means it lost an H plus one ion. So it is losing H. It lost an H plus one. So it acts as a proton donor. That's true. NaCl is a salt. Remember, Bronsted-Lowry acid-based reaction has no concept of a salt. It's just that an acid is going to produce an H plus one and a base is going to accept an H plus one. So so NaCl is a salt. It's definitely a salt. Uh, but it's I mean that has nothing to do with Bronsted-Lowry. acid-base theory or acid-base reaction, or that does not actually guarantee that it's a Bronsted-Lowry acid-base reaction. ठीक है? Is this clear? ठीक है, Minal, is this clear? Ethan, is this clear?
Yes.
Uh,
Yep.
then ammonia is always basic, which it's not, because if you look at this reaction, you can see that ammonia is forming NH2 minus 1 ion. So that means it's capable of forming, so it might lose H plus 1 to form NH2 minus 1. So if it does that, that means it's behaving as an acid. It lost an H plus 1. So ammonia is always basic. Not true. It could lose an H plus 1 as well, as shown in the equation. Now the next one is, I mean, we can ignore this. This is equilibrium. Let's talk about this question. The table gives the concentration of pH values of the aqueous solution of two compounds X and Y. Either compound could be an acid or a base. Uh, and the pH values are stated. Both are having a concentration of 2 mole per dm cube. Now remember, there's a pH scale. So there's this scale where 7 is the middle, and then above 7, a lot of people think that 14 is the limit, but it's not. It can be higher than 14 as well. Any value above 7, that's basic, and any value below 7, that is acidic. That is considered acidic. Uh, so the first is student Q concluded. So student P concluded that X is a strong acid. Is he right or not, or wrong?
Wrong.
ठीक है, pH6 is not a strong acid. ठीक है, so that's wrong. I mean, student P is wrong. Uh, so that means the answer is D, because which students are correct? Both P and Q. So it could be B as well. I mean, B could be an option as well. But this one and this one are now incorrect. Student Q concluded that the extent of dissociation is lower in X than in Y. So which one is dissociating more? X or Y? Remember, they're both different substances. Uh, but we are talking about, I mean, this one is an acid and this one is a base. Okay, what does a base do in solution? It accepts H plus ions. An acid does the opposite. It produces H plus ions. Who's ionizing more? Uh, whose strength is more?
X.
Remember, seven is the neutral point. Okay? The further you are from 7, that's your strength. Okay? To answer this question, I have to give you a brief idea of what pH is. Okay? Let me just briefly, although this is not required, let me just very briefly tell you what pH is. Okay? If you don't know this already, and what's the pH scale? Where do you get the pH scale? The pH scale is that there's a thing that happens that the pH scale only applies to water. It's basically water, and water has this thing that it. Let me write it here. So water has this thing that it ionizes very very weakly. It produces H plus 1 and OH minus 1 ions, right? So it produces 2 ions. But the amount of ions, remember, this is not important. I'm just going to give you or develop an understanding of what pH is. Uh, both ions have a very low concentration in pure water. It's 1 into 10 power minus 7 mole per decimeter cube, and this one is also 1 times 10 power minus 7 mole per decimeter cube. So water has 2 ions, and this only happens. This is what we are talking about: water at room temperature at 25 degrees centigrade. Now, what is pH? pH is actually the negative log. So pH is the negative log of the H plus 1 concentration, right? Uh, so you're just taking the negative log of the H plus 1 concentration. Does anyone have a calculator and take the negative log of this very quickly? I mean, this is the H plus 1 concentration. And this at the moment is just neutral water.
7, right?
Okay, so it's coming out to be 7. So this is neutral water, and the H plus 1 concentration, if you take the negative log of 1 times 10 power minus 7, you're going to get 7. Now the first thing is, why do you even take the log? What's wrong with? I mean, why don't we just talk about 1 into 10 power minus 7? Why do we need to take log? The thing is, that log is a method to simplify things, uh, and it helps to make graphs. You make very good graphs if you take log, because plotting 1 into 10 power minus 7 on a piece of graph paper, that's impossible. pH is one of the most important things, because water is everywhere. Every solution contains water. Every cell that we have contains water. So the balance of H plus 1 and OH ions is very, very important, because if the pH changes, if this balance changes in the solution, then your reactions would stop happening, or those that are not happening would start happening. And so everything depends on this. Uh, now, so we have to track pH everywhere. For example, if you're planting crops, you're going to check the pH of the soil. That's the first thing. The composition of water is always very, very important to any reaction, because that's the main medium in which reactions are happening. Uh, so the problem is, you can't really track this value. I mean, what is this value? It's point. How many zeros? That's like 6 zeros. You can't really plot a graph using this value. Uh, so which is why, if you take log expresses the same value in the powers of 10. If you express the value in the powers of 10, this is 10 to the power minus 7. The reason you put a negative sign is so you can get rid of the negative values, so that your value comes out to be positive. And you're getting 7. Now plotting 7 on a piece of graph paper, that's very convenient. That's like a whole number that can easily be plotted. Okay, is that clear? Ethan, is this clear? Binail, clear? Isa, is this clear?
Yes.
Yes.
Okay. So, I mean, there's nothing wrong with this value. It's just that it's not a very convenient value to play with. You can't even communicate this value properly to someone. Like telling someone pH is 7, that's easy. Telling someone that it's 0.0000001, that's difficult. So, I mean, that's what log does. That's why we values, especially values which are not whole numbers. Like if you want to communicate, I say, if you want to communicate this number to someone, or you want to plot this number on a piece of graph paper, if you take the log of this would come out to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's the log is going to come out to be 9. Plotting 9 is very convenient. So which is why you use the log of H plus 1 concentration, and the negative sign is just to get rid of the negative sign, because this is going to be 10 power minus 7. So the value should have come out to be minus 7. You don't want to deal with the negative term, so you just multiply the thing by negative. I say, anyways, now the thing is that if you increase the H plus 1 concentration, the OH ion concentration automatically decreases. Uh, that means the solution has become acidic. It's no longer neutral. You've added a molecule that has increased the H plus 1 concentration, and the OH ion concentrations have decreased. So let's say the new concentration of H plus 1 in the solution, because you've added an acid, is now zero point zero 0.02 mole per dm cube. Can anyone tell me what is the pH now? What's the negative log of this?
1.7.
So it's coming out to be 1.7. So as the H plus one concentration keeps on decreasing, increasing, the pH value keeps on decreasing, and so the pH value keeps on decreasing. Vice versa, if the solution is basic, what would happen in a basic solution? In a basic solution, the OH ions would be a lot more, the H plus one ions would be a lot lesser. So let's say it's 1 times 10 power minus 13. So the concentration of H plus 1 has decreased a lot because you've made the solution basic. You've added a base, and the base has consumed all the H plus 1 ions, and the amount of H plus 1 ions in the solution is very, very less now. What would immediately happen? The pH would start to rise because if you take the negative log of uh, this would come out to be 13. Okay, so that's the basic idea of what a log is. Now, what I wanted to discuss was that it doesn't matter whether you're. I mean, if you're at pH 7, basically that, and if you drift away from pH 7, whether to the right or whether to the left, the strength increases. I mean, on the left side, the strength as acids increases, and on the right side, the strength as bases increases. And what we mean by strength is the amount of ions or the amount of dissociation. Like if something dissociates less, then the pH would be around 6 or 7. So, I mean, in our question, we were given a value of pH 6. I mean, strength increases, more dissociation, basically. And on this side, as the strength of bases increases, there's going to be more dissociation, more ions in the solution. I say he was comparing pH 9, I think. Now, who's further away from pH 7? The value that's further away from pH 7, that's the one that's going to dissociate more. So pH 9 is further away. That means it's going to dissociate a lot more compared to pH 6. Is this concept clear? Minahil, is this clear? Aiza, Ethan, Mohammed, is this clear?
Yes.
Yes, sir.
ठीक है.
Yep.
So remember this scale, remember the concept that what is pH? You're just taking negative log of the concentration of H plus 1. In an acid, the H plus 1 increases. In a base, the H plus 1 decrease. Uh, the closer you are to pH 7, that's less dissociation. The further you're away, whether to the right or whether to the left, you're going to be dissociating more. So in this question over here, they were saying that student Q concluded that the extent of dissociation is lower in X, which is true because 9 at pH 9 there's going to be more dissociation. That's the one that's going to dissociate more. So there's going to be more dissociation in this case, which is why Q is correct. P is wrong. The next one is which statement are correct in terms of Bronsted Lowry acids and bases. Water can act as either an acid or a base, which I did discuss that water, it can produce H plus 1 ions. So if it's capable of producing H plus 1 ions, it's capable of acting as an acid. But at the same time, I told you that if you have water, so if you have water and it so if you have water and it you reacted with HCl, The HCl would dissociate, ionize, and it would produce this hydronium ion. Uh, Water has lone pairs which can directly bond and capture H plus ions in the solution. So water can act as a base as well. So the first statement is correct. Uh, the next one, first clear. Ibrahim, is this clear? Mohammed, is this clear?
Yes.
Yes.
So then you have sulfuric acid does not behave as an acid when dissolved in ethanol. I told you initially when we were doing the first question. Where's the first question? Okay, this one. I told you that for an acid to behave as an acid, there must be a base present. These things they can't operate on their own. Like acid would not lose an H plus one if there is nothing there that's accepting H plus one ions. And similarly, if there is no acid, there is no base. Like if there is a base present and there is no acid, the base would not be able to accept H plus one ions because it would not be able to find H plus one ions in the first place. So for an acid to behave as an acid, you need a base, and for a base to behave as a base, you need an acid. So will the sulfuric acid ionize in the presence of ethanol? Where's the question? Can it behave as an acid in the presence of ethanol?
Yes.
Okay, it does. Why does it behave as an acid?
Because ethanols are slightly basic. They can ionize.
The ethanol is slightly uh,
Basic.
not basic. They're acidic actually. Okay, ethanol has this tendency to lose H plus ions. Okay, to form O minus one and H plus one. Okay, so ethanol is slightly acidic basically, and very slightly, almost they non-existent. Okay, they don't really behave as acids. They
So, but why can't it lose an OH ion?
Cassius,
मतलब कि why can't it lose an OH ion instead of simple hydrogen?
uh, this one,
Yes.
I mean that is possible, but for that to happen, you would have to break the carbon bond. Carbon usually bonds with carbon are stable. It's going to be a उसकी reason मैं बता देता हूँ just a second. So for example, you can have a nucleophilic substitution reaction. How do I rub this? All 1 second. So for ethanol to behave as bases, this bond is usually very stable. The carbon O bond is a lot stronger compared to and a lot more stable because it's kind of non-polar. It's this bond that is highly polar. Okay, because of the polarity mostly. Because there's a water molecule around, then the water molecule and the negative part, especially the oxygen lone pairs have a very strong negative charge. So they're going to attack the H positive. I mean, the other side, the carbon chain is kind of non-polar. It's not going to get attracted, which is why this bond is not going to be affected that much. The H is the one that's going to be pulled towards this lone pairs on oxygen. Okay? Ibrahim, is this clear?
Yes.
So, which is why it's usually the H that is dissociating, not the other way around. I say, anyways, uh, the thing is, sulfuric acid does not behave as an acid when dissolved in ethanol, which is true because you need a base at the other end. Gee, you need something that would be capable of accepting H plus ions. You need a base, but the problem is ethanol itself is losing H plus ions. So how can it? Uh, I mean, there would be too many H plus ions in the solution. Uh, so you need a base at the other end. Somebody should be there to accept the H plus ions, which is not present. Uh, and is that clear?
Yes.
As the last part is the ammonium ion acts as a base when dissolved in liquid ammonia. The ammonium ion is never going to act as a base because it can't accept any more H plus ions. This is the ammonium ion. Ammonium ion acting as a base means that it's capable of accepting more H plus ions, which is not true. It has already accepted 4 H plus ions. There's no more capacity. Ammonia, if you look at nitrogen, it had only 4 orbitals or 8 electrons in its outer shell. So its electrons are full. There's no more space available. The only thing that it could do is that it could let go of some H plus ions. So it's capable of acting as an acid, not a base. Okay, it would not be able to accept more H plus ions. Is this clear? Ethan, is this clear?
Yes.
Okay.
Yeah.
As the next one, so we did this. Let's talk about this one. Uh, the question is that there's tooth enamel, which is this thing, and in the presence of saliva, the following equilibria exist. Which of the following statements helps to explain why tooth enamel is dissolved more readily when saliva is acidic? So, if saliva is acidic, uh, what would happen? What's going to happen is that the OH ions are going to be lesser. I mean, the acid would neutralize the OH ions. So if the OH ions are gone, the equilibrium would shift and would try to produce more OH ions, right? So which is why your tooth enamel, which is this thing over here, it's going to start dissolving. So H plus 1 would remove the OH ions in the solution. So that's one reason. So then what else? Uh, if the saliva is acidic, what would happen? That the H plus 1 would be more in quantity and the equilibrium would shift backwards and there's going to be less phosphate ions. So if there are less phosphate ions in the solution, the first equilibrium would again shift to the right. So there are two reasons why having acidic saliva would dissolve the tooth enamel. The first one is that hydroxide ions are neutralized by the acid. That's true. Lesser OH ions, so equilibrium shifts forward. The phosphate ion accepts H plus 1, which is true because if there's more H plus 1 ions, the phosphate ions would react with the H plus 1 to form this thing. So the phosphate ions would be gone. And the first equilibrium would again shift to the right. Calcium ions don't react with acids. That's incorrect. Like calcium ions, acid is H plus 1, no reaction whatsoever. Okay. Is this clear, this question? Okay. Ibrahim Mohammed, is this clear?
Yes.
Yes.
The next one is concentrated sulfuric acid behaves as a strong acid when it reacts with water. So one other very interesting thing is that if you look at any acid, let's say sulfuric acid. Sulfuric acid has this structure. It has S double bond O, and there are three OH groups. No, just two. It actually has two double bond oxygen. So this is H2SO4. Now, a lot of you think that H2SO4 dissociates in one go, and it's not a reverse. I mean, we think of it as a strong acid, and we think that it's going to produce two H plus one ions and one SO4 minus two ions. This is known as a diprotic acid. Or a dibasic acid. Okay, these are some of the terms like phosphoric acid is H3PO4, that's a triprotic acid or a tribasic acid. Then you have monobasic or monoprotic acid, which are like HCl. Okay, that's a monoprotic acid. Now the thing is, what happens if you have a diprotic or a triprotic acid? The thing is, acids don't lose their H plus one in one go. Like, I mean, this is not going to happen. That it's going to immediately produce two H plus one ions. It's going to do this stepwise. Like, it's going to first let go of one H plus one ions, and then it's going to try and let go of the second H plus one ions, right? So what's going to happen is there would be two steps for the dissociation. H2SO4 goes and releases one of the H plus one ions, and SO4 minus 2 ion is produced. So let's say this H plus 1 over here, it has been removed. And an HSO4 minus 1 ion is formed. And in the next step, the HSO4 minus 1 ion releases another H plus 1 ion, and it produces SO4 minus 2. Now the question is, so sulfuric acid would be behaving as two acids. Okay, if it's a diprotic acid, it would be behaving as two acids. One of them is going to be H2SO4. The other one would be HSO4. Like in the first step, H2SO4 is the one that's losing H plus 1 ions. And in the second step, it's HSO4 minus 1 that's producing H plus 1 ions. Okay, is this part clear? Isaiah, is this clear? Minahil, clear? Ethan, is this clear?
Yeah.
Which one do you think? The first one or the second one? Whose dissociation would be easy? Like for the first molecule, is it easier to lose H plus 1 ion, or is it easier to lose H plus 1 ion for the second one?
The second one.
Focus on the charge. The second one has a charge of -1. The first one had zero charge. So if a molecule has a negative charge, would it attract H plus 1 or would it lose H plus 1 ions?
Attract.
So this one would be kind of difficult. I mean, it would be a lot difficult if the ion is negative. A negative ion is not going to produce, or it's going to be very difficult for it to produce H plus 1 ions because it's going to be attracting H plus 1 ions. And the first dissociation would be easy. So the first molecule is going to behave as a strong acid, but the second one is going to behave as a very weak acid. Because so this first step is easy, the second step is kind of more difficult. Is this clear? Minahil, clear?
Yes, sir.
Yes.
Okay, and the same would happen with H3PO4. Like if H3PO4, I mean H3PO4 is not going to produce three H plus 1 ions in one go. It would first release one of the H plus 1 ions, and it would form H2PO4 minus 1. Then this other molecule would behave as an acid, and it would produce another H plus 1 ion, and it would become HPO4 minus 2. And finally, the third one, which is H would lose an H plus 1 and it would form PO4. I said it would form PO4 minus 3. So the thing is that the first dissociation is going to be very easy. No charge, easy to lose H plus 1. The second becomes difficult. And why does it become difficult? Because it's now a negative ion. It's more likely to attract H plus 1 rather than. And the third one is even more difficult. A lot harder for this one to lose an H plus 1 because it's now -2. -2 is going to attract H plus 1 very strongly. It's not going to release an H plus 1 ion. So remember, only the first dissociation is the one where the molecule acts as a strong acid. The rest kind of becomes weaker and weaker. So this question that we were doing, it's about that he's saying that sulfuric acid behaves as a strong acid when it reacts with water. So the first dissociation, it's behaving as a strong acid. But then he's saying that the HSO4 minus 1 ion behaves as a weak acid. So this dissociation is weak. So if you use 1 mole per dm cube sulfuric acid, is the first option correct or incorrect? Like, give me a figure. How much H plus ions would be produced? If you're starting with 1 mole per decimeter cube. क्या होगा इब्रार? Any answer?
Is it also 1?
ठीक है, because the first time it's dissociating that's strong, so it's going to be 1 mole per dm cube, right? But that would also give you 1 mole per dm cube of HSO4 minus ions. So you have 1 mole per dm cube of HSO4 minus 1 ions. But the problem is that the second time it dissociates, that's very, very less or almost non-existent. So let's say very few H plus 1 ions are produced. So the total amount of H plus 1 ions would be 1 plus, let's say, 0.01. So it's approximately 1.01. So it's most of the H plus 1 are going to be produced with the first dissociation. Mohammed, is this clear? Ethan, is this clear?
Yeah.
Yes.
Achha, so H plus 1 concentration is going to be high because at least the first dissociation is happening. The SO4 minus 2 concentration is not going to be high because SO4 minus 2 is produced in the second step over here. So that's not going to be high because the second dissociation is not happening or happening very, very weakly. So the SO4 minus 2 concentration is not going to be high, and these two are not going to be equal. Like, you would have a lot of HSO4 minus ions, but you won't have a lot of SO4 minus 2 ions. Is this clear? Minail, is this clear? Ibrar?
Yes.
Yes, sir.
Okay, so remember this minor point, small point, that diprotic, triprotic acids, they don't ionize in one go. So the rest is really easy. We can continue with this. We'll do some other small topic as well next time. Okay. Okay then. Take care.
Chalo, Hafiz, sir.
Hafiz.
Thank you.
Thank you.